It's not possible. Listen, if there's one thing the history of evolution has taught us, it's that life will not be contained. Life breaks free, it expands to new territories, and it crashes through barriers painfully, maybe even dangerously, but, well, there it is.
Life finds a way, Dr. Ian Malcolm famously quipped in Jurassic Park. But what happens when nature decides it's finally had enough? Deep beneath the picturesque landscapes of Yellowstone National Park, a slumbering giant stirs. From Old Faithful's clockwork eruptions to the prismatic hot springs, Yellowstone's geothermal wonders have long captivated visitors. Yet these beautiful features hint at a far more powerful force lurking below, a force that has shaped continents and altered global climates in the distant past. As scientists continue to monitor this geological time bomb, one unsettling question looms. Could the Yellowstone Supervolcano erupt tomorrow? The sleeping giant. Beneath the picturesque landscapes of Yellowstone National Park lies a slumbering behemoth, the Yellowstone Supervolcano. This geological marvel is not just a volcano, it is the volcano. The entire park sits atop a massive volcanic system that has shaped the region for millions of years. The Yellowstone caldera, measuring an impressive 43 by 28 miles, is the visible remnant of past cataclysmic eruptions. But what makes this volcano super? It's the sheer scale of its potential eruptions. Supervolcanoes are capable of ejecting more than 240 cubic miles of material, enough to bury Texas under 5 feet of ash. This sleeping giant has awoken before, with devastating consequences. Over the past 2.1 million years, Yellowstone has experienced 3 major eruptions, each leaving an indelible mark on the North American landscape. The most recent of these epic events occurred approximately 640,000 years ago, creating the caldera we see today. A hotspot on the move. The Yellowstone supervolcano owes its existence to a geological phenomenon known as a hotspot. This is essentially a plume of molten rock rising from deep within the Earth's mantle. While it appears that the hotspot has been moving across the landscape, creating a trail of volcanic activity, it's actually the North American tectonic plate that's been sliding over this stationary heat source. This journey of the continent over the hotspot has left a trail of calderas and volcanic fields stretching from the Nevada-Oregon border through the Snake River Plain of Idaho, finally terminating at Yellowstone. Each eruption along this path tells a story of the Earth's dynamic nature and the immense forces at work beneath our feet. The Yellowstone hotspot's origin remains a topic of scientific debate. Some researchers propose it's the result of complex interactions between local conditions in the Earth's crust and upper mantle convection. Others argue for a deep mantle origin. The sudden appearance of the hotspot in the geological record and its coincidence with other volcanic events, like the Columbia basalt flows, only add to the mystery. The anatomy of a supervolcano. Understanding the Yellowstone supervolcano requires delving into its internal structure. Beneath the park lies a complex system of magma chambers. The primary chamber is a behemoth, stretching 50 miles long, 12 miles wide, and containing an underground volume of over 960 cubic miles. However, it's crucial to note that this chamber isn't a vast pool of bubbling lava. Instead, only about 5 to 15% of this volume is actually molten rock. The rest is a crystal mush, a partially solidified mass of rocks and crystals interspersed with pockets of magma. This magma reservoir is fed by the heat from the mantle plume below. As magma rises, it brings with it dissolved gases. The interplay between these gases, the pressure within the chamber, and the surrounding rock creates the dynamic system we observe at the surface. Surface manifestations. While the volcano itself slumbers, its presence is unmistakable across Yellowstone. The park's famous geysers, hot springs, and mud pots are all surface expressions of the heat simmering below. Old Faithful, perhaps the park's most iconic feature, erupts with clockwork regularity due to the complex interplay of heat, water, and underground chambers. These hydrothermal features aren't just tourist attractions, they're windows into the volcanic system below. Scientists carefully monitor these features, as changes in their behavior can provide valuable insights into what's happening deep underground. The ground itself tells a story. The Yellowstone caldera breathes, rising and falling as magma and gases shift beneath the surface. In recent years, parts of the caldera floor have been rising at rates as high as 2.8 inches per year, though this uplift has slowed in recent times. Monitoring the beast. Given the potential consequences of a Yellowstone eruption, it's no surprise that the volcano is one of the most closely monitored on Earth. The Yellowstone Volcano Observatory, a collaboration between the U.S. Geological Survey, Yellowstone National Park, and the University of Utah, keeps a constant vigil on the sleeping giant. Their arsenal of monitoring tools is impressive. Seismometers detect even the slightest tremors, while GPS stations track ground deformation with millimeter precision. Gas sensors sniff out changes in emissions from fumaroles, and satellite data provide a bird's-eye view of thermal and deformation patterns. This network of instruments generates a constant stream of data, painting a real-time picture of the volcano's state. Any significant changes would be quickly detected, providing crucial early warning of potential volcanic activity. Earthquakes, nature's constant companion. Yellowstone is a seismically active area, with 1,000 to 3,000 earthquakes occurring annually. Most of these are too small to be felt, but they provide valuable information about the state of the volcanic system. Occasionally, the park experiences earthquake swarms, clusters of seismic events occurring in a short period. While these swarms can be unnerving, they're a normal part of Yellowstone's geology. They're typically caused by movements along existing faults rather than by magma movement. However, earthquakes and volcanic activity can have a complex relationship. Large, distant earthquakes have been known to affect Yellowstone's hydrothermal systems. For example, the 1992 Landers earthquake in California, over 800 miles away, triggered a swarm of quakes in Yellowstone. The eruption scenarios. When discussing Yellowstone's future, it's important to consider the full spectrum of possible volcanic activity. While the prospect of a cataclysmic supereruption captures the public imagination, it's actually the least likely scenario. The most probable future event is a hydrothermal explosion. These occur when superheated water flashes to steam, causing a violent eruption of rock and boiling water. While localized, such events can still be dangerous. Over the past 14,000 years, at least 20 large hydrothermal explosions have occurred in Yellowstone. Next on the probability scale are lava flows. These wouldn't be the fast-moving rivers of lava seen in Hawaii, but rather slow-moving, thick flows that could cover significant areas over weeks or months. The most recent lava flow in Yellowstone occurred about 70,000 years ago. A more explosive scenario would be a smaller eruption, similar in scale to the 1980 Mount Street Helens event. This could produce significant ashfall and pyroclastic flows, causing regional disruption and damage. The least likely but most impactful scenario is a full-scale supereruption. This would eject hundreds of cubic miles of material, blanketing much of North America in ash and causing global climate effects. However, the chances of this occurring in any given year are vanishingly small, less than 1 in a million. The aftermath of a supereruption. While a supereruption remains highly unlikely, understanding its potential impacts helps put the risk in perspective. If Yellowstone were to experience such an event, the immediate vicinity would be devastated. The eruption would likely begin with increasingly intense earthquakes, ground deformation, and changes in hydrothermal activity. As the eruption progressed, it would eject enormous volumes of ash, rock, and gases high into the atmosphere. Areas within a few hundred miles could see ash accumulations of several feet, crushing structures, choking rivers, and destroying vegetation. Further afield, a layer of ash would blanket much of North America. Even a few inches of ash can disrupt transportation, contaminate water supplies, and cause respiratory problems. Agriculture across the continent would face severe challenges. The global effects would be profound. Sulfur dioxide ejected into the stratosphere would form a haze of sulfuric acid droplets, reflecting sunlight and cooling the planet. This volcanic winter could last for years, disrupting climate patterns and potentially leading to crop failures and famine in vulnerable regions. However, it's crucial to emphasize that such a scenario, while dramatic, is extremely unlikely. The geological record suggests that supereruptions are very rare events, occurring on timescales of hundreds of thousands of years. Living with a supervolcano. Despite its potential for destruction, the Yellowstone Supervolcano is also a source of life and beauty. The heat from the magma chamber drives the park's unique ecosystems, supporting a diverse array of plants and animals. The volcano also offers a unique opportunity for scientific research. By studying Yellowstone, scientists gain insights into the Earth's inner workings, volcanic processes, and the interplay between geology and biology. For the millions of visitors who come to Yellowstone each year, the park offers a rare glimpse into the raw power of our planet. From the clockwork eruptions of Old Faithful to the prismatic colors of Grand Prismatic Spring, the volcano's surface expressions are a constant reminder of the forces at work beneath our feet. As we continue to study and monitor this geological wonder, we're continually improving our understanding of supervolcanoes and our ability to forecast volcanic activity. While Yellowstone's future remains uncertain, one thing is clear: this sleeping giant will continue to shape the landscape and capture our imagination for millennia to come. Now it's time to hear from you. As Dr. Ian Malcolm might say, life finds a way. But what about volcanoes? Do they always find a way to erupt? Or could Yellowstone's slumbering giant remain dormant indefinitely? What fascinates you most about the Yellowstone Supervolcano? Is it the potential for catastrophic eruption or the everyday wonders it creates in the park? Share your thoughts in the comments below. And here's a burning question. If you could ask a volcanologist anything about Yellowstone, what would it be?